Okay, and sometimes when you're doing these substitution problems, you don't have an equation that's set up all nice, like in the form y equals or x equals, and you need to solve one of the equations for y or x to substitute into the other one. My recommendation is to look for variables that either don't have a coefficient or just have a negative in front of them. Those are easier to solve for, but again, it doesn't really matter. You just need to get one of the equations in the form of y equals, meaning y all by itself, no negatives, no coefficients, y equals something, usually like 2x plus blah blah blah, or in the form x equals something. So this equation here is actually set up pretty nicely to solve for y, because the y is all by itself, it doesn't have a coefficient. So if I bring this over here and solve this for y, I would do that by subtracting 4x from both sides. And that would give me y equals 11 minus 4x, because we can't combine the 11 and the 4x because they're not like terms. The 11 doesn't have an x attached to it, so you can't combine those two terms. So you're just going to get 11 minus that 4x. And now I'm going to plug this in for y into this second equation, the one I haven't used yet. So I now have 2x plus 5 times all of this. This whole thing is now what is becoming y. So we've got 5 times 11 minus 4x, and that's going to equal 1. Okay, and now I need to simplify this side so that I can get it down to just a single x term and then a coefficient that I can move over to the other side. So if I multiply the 5 through to both terms here, I will have 2x, that doesn't change, plus 55 minus 20x, and that still equals 1. Okay, and now I can combine the like terms that I have on this side, which are this 2x and this negative 20x. So a positive 2 plus a negative 20 would give us a negative 18. So I've got 55 minus 18x, and that equals 1. And then I'm going to subtract 55 from both sides, and that will leave us with a negative 18x on this side, and that equals a negative 54 on this side. And if I divide both sides by the negative 18, that gives us an x value of positive 3. Okay, and now, again, like I did with the last problem, I'm going to take that value and plug it back in to one of my equations here and solve for y. So I will have, if I plug it into the first one, I've got 4 times 3 plus y equals 11. So this is 12 plus y equals 11. And then if I subtract 12 from both sides, I would get y equals negative 1. So your final answer, therefore, is the point 3, comma, negative 1. Please let me know if you have any questions.